So again, in this video we're going to look at developments again, but in this case we're going to look at a square-based pyramid. So a square-based pyramid, as the name says, we're going to start off with a square on the base. So again, working on an A4 page, or we can use card or any paper that we have left lying around. So in this case, I'm going to draw the base of this pyramid. Again, I'm taking any size here, but for the video I'm going to say it's going to be 50 millimeters long. So the length of this space is 50 millimeters and the height of the square is also going to be 50 millimeters. So from each side of that 50 millimeter line, I'm drawing vertical lines up. And again, the easiest way to get a very exact square is to use my 45-degree set square, and that draws a perfect base of this pyramid. So 50 millimeters by 50 millimeters. So to draw the four sides of this square-based pyramid, I'm going to draw an equilateral triangle at each side of the square. So there's a couple of ways of drawing an equilateral triangle. First thing that we need to know is that all sides are going to be the exact same and all angles are going to be the same. So one way is I could use my 60-30 degree set square and draw a 60-degree line from each side. That would give me an equilateral triangle, or what I prefer to use, and it's more accurate, is to use my compass. So the compass here, I'm going to set it to the length of one side, which is 50. I'm going to swing an arc from each side off that line, and what I'm after creating is a perfect equilateral triangle. All sides are the same, all angles are the same, and hopefully we know that all angles in a triangle, if we add them all up, it is always going to come to 180 degrees. So I'm going to repeat that process from each of the four sides of the square-based pyramid, using my compass to swing an arc 50 millimeters long. So I'm going to have four equilateral triangles joined on to the square base. So hopefully we remember from the last video is we will need to include some broken lines or some dotted lines. So broken lines or dotted lines gives an indication where we're going to fold these lines. All heavy lines, that gives an indication of the lines that we are going to cut out. So again, if we were drawing this up someplace and sending it off to get it manufactured in a different country or with a different company, it is important that we follow the same procedure. So heavy lines are lines that are going to be cut, and broken lines are lines that are going to be folded. So we should now be able to see exactly the lines that we are going to cut out. So once I've all of the lines heavy, then we're going to take the page off and we're going to cut it out with a scissors or a knife. So if we need some help, we can get somebody older or somebody more accurate to cut out the lines for us, and then we're going to bring it back and we're going to fold it. So hopefully we can see now how this is going to make our square-based pyramid. Our four sides are going to bend up and they're going to meet at the apex. So the apex is the word that we give to the top of a house or the top of a triangle, or in this case the apex is going to be at the top of our square-based pyramid. So here I have it cut out. We can see our dotted lines, and again, what I find the easiest way to fold our lines accurately is to use our two set squares, and it gets a very sharp fold line. Again, if we're using cardboard, we'll have to be extra forceful when we're trying to fold these lines. So once all that is done, we can see how this 2D page is after turning into a 3D shape. I'm going to use a little bit of tape just to tape it all in, and what we have is a perfect square-based pyramid, and the base of the pyramid is 50 millimeters by 50 millimeters.